This will be the video about creating animation. The command is called manipulate. So this is a very nice way to present something that's changing continuously or discretely as we vary something, so-called a parameter. So I'm looking at this function. I just made up one so that it behaves interesting to see. So this is a function where the main variable here is x, and c is a parameter, and it's a constant that changes. So as we change the c to something else, this function behaves slightly different. So we'd like to present how this the graph of the function changes as we change this parameter c. So as you can see, what you see in this part from here to the end is a picture, the plot command. So this whole figure is stored as a figure with a name figure, and as we change the c, and this whole picture will change. So this is controlled by this c parameter, so you can define it like this. And this a and b are something that I don't know, so I'm going to change it later on. So if I put it this way, it's easier to change. What this is going to be is the limits of the windows of the picture, so that I captures the interesting part. So I'm defining it like this so that I can easily change it later. So this is the command. I defined all this picture. If I change this value c, it's gonna sketch the different picture. So manipulate kind of put those all things into one picture. So the show is a nice way to do this. To show this picture I defined, if I change this parameter c, it's gonna show continuously how it changes. And this, and I've shown that, explained in an earlier video, this is gonna be the window size. And the last bit is that this entire part up to here is the graphic element. You have to put one single graphic element, and there's a row and column command if you want to show multiple things in a separate, juxtapose each other, not all together in the same coordinate system. Then you have to use a command, something called row and column, to put together and juxtapose them. But if you use show, it's gonna put everything into one coordinate system. So we have right now one picture at a time to show, so that's gonna do it. This entire thing is a one graphic element, and it changes as we vary the c. C is going to start from -5 and change to +5, increasing by 0.01. If you omit this one, it's going to choose some default value. So let's run this. When you run it, it shows this picture. I have to make it a little bit smaller so that it fits into the window, and there's this button. If you click on it, you have a control button. So if you play this one, it's going to play a video, and this is playing the video a little bit slower, so I'm going to hit like in one time, and this is going backward and forward and forward and backward, and making a continuous loops. And see how this function varies. C was -5, so let me show the function again. Function was this sine function with x as the main variable, but as we change the c, the graph of this function changes. So here's the c, and let's see how it changes. Just hit the play button. Okay, it was moving, changing too fast, so I hit this slower button a couple times, and I decided to show from here about to here, and then video is a little bit slower and easier to see. So let's see what happened, how this function changes. This is I made it even more slower, and this is how the as c passes 0, it began to pick up a speed and begin to change a lot. And so that's the shape of the graph. So let's look at the second example. Right, here's our second example. This is going to be ball thrown upwards, and by gravity is going up and coming back down. And the height as a function of time t is supposed that is given by this quadratic formula, which is actually close to reality. It's just a different coefficient, but the degree and the kind of class of a function is a correct function to capture the phenomenon on the surface of the Earth. And this is a function, defined properly, and figure 2 will be just a graph of this function between 0 and 5. When t equals 0, the height is 0. When t equals 5, and it hides the 0 again. So this is when it comes back down to the beginning position. And I put some color so that I can distinguish it easily. So figure 2 is not dynamic, it's not changing, it's a static picture, just one picture, the whole graph. Next one will be that you can see this is a picture list plot here. So it's controlled by T. So we're plotting 3 points here. You can see this is 1 point, and this is the second point, and the third point. This is actual T equals 0, so we're not really visualizing the T. T is something you don't see, but height you see, so it's going up and down. And this is actually part of the graph where you see the t-axis. And this is something I want to sketch to explain later. So there I'm sketching 3 points, all of them in red, and this is the size of the point. So this is changing. This picture is changing every time we have a different t. This point is changing. So this figure 3 is a graphic element, but as we change this t, the locations of these points change. Like the last time, I put this BB so that I can find the correct range to show. So that BB appeared in there. So what we're going to do is that we're going to show the figure 2, which is just a parabola, not changing. But figure 3 is as t changes, this is going to be different positions of the 3 points. And we're just zooming into this t-axis varying from 0 to 5, and y-axis varying from 0 to BB. I found the 7 is showing everything. And t is changing from 0 to 5, and I did not specify the increment. So it's going to choose this default value 100th or something. So if you do that, and let's see what happened. Okay, this is a picture we get. So those are the 3 points all put together in the same position at the beginning. If you click on this button, you have a control. I'm going to make it a little bit slower. And as you play that, and I'm going to make it into a continuous loop. As you play, then you're going to see this 3 points, how the 3 points behaving. Make it a bit slower. So this point is going through the parabola, and this is actually the ball is thrown upward and reach the highest points and then coming back down, and these 3 points, this point is kind of correspond to, and this is kind of shadow. This is not really the trajectory of a ball, so I better not have this one, but this is actual trajectory of a ball. Ball is actually going up and down, and this point here in the middle is in the space of a space-time. This is actual space, and this is a time axis. So this is typical Newtonian space-time picture.